Today we'll be discussing section 8.5, which is about hyperbolas. We'll be able to graph hyperbolas and write equations of hyperbolas given certain conditions. On this page is the definition of a hyperbola. A hyperbola is the set of all points P in the plane such that the difference between the distance from P to two fixed points is a given constant. These fixed points are foci. A hyperbola of two foci. What a hyperbola looks like is a set of two parabolas, either both going up or down, or both going to the right or left. What the definition is describing is if you pick any point on the hyperbola on either one of the curves, and if you measure the distance to each focus, and then subtract those distances, you will get some constant. If you pick another point on either of the branches and find the distances between that point and the foci, and again you subtract them, you will get the same constant. There are two vertices to a hyperbola, one for each curve. There are two foci, one found inside of each curve, and the curves are actually called branches. Okay, we're going to refer to them as branches. Branches either go up or down or right or left. There are two forms to the equation of a hyperbola. You have a standard form equation for the branches that are going right and left. Notice it starts with x. The way I remember it is the x coordinate is your right-left coordinate. If you start with x, your branch is open to the right and left. Then you have your form for when it goes up and down. Notice that starts with the y. Y is your up and down coordinate, and that's how I remember it. Other key features to a hyperbola is it is subtraction. That's why the order matters. Subtraction is not commutative. Notice the h and k are still attached. H is attached to x like it always is. K is attached to y like it always is. So when you're finding your hk, which will be your center, look for those values. Also, A is always under our x. A represents how far right and left from the center, like an ellipse. B is under our y, like an ellipse, up representing how far up and down. So the important points. HK is the location of the center. Yes, a hyperbola has a center. A is the distance to the right and left. B is the distance up and down. Very similar to an ellipse, we'll be placing points right and left from the center and up and down from the center. The vertices are always found on these branches. We will be finding a C value. C is the distance from the center in the direction of the branches where the foci are found. C is always found by taking the square root of a squared plus b squared. It is addition, so it really doesn't matter if it's a squared plus b squared or b squared plus a squared. There will be asymptotes, and we'll describe what the asymptotes are as we see an example, but we will be finding the slopes of these asymptotes. The slope is always plus or minus the b value over a value. Okay, the axis where the vertices are found is always called the transverse axis. The other axis, which is always perpendicular to it, is called the conjugate axis. We'll be using this when we write equations. So again, if the branches go up and down, the vertical axis is your transverse axis. If the branches are going right and left, then the horizontal axis is your transverse axis. So your transverse, again, I'll say it again, the transverse axis is the axis in which the vertices are found. Okay, the other axis is always called the conjugate axis. Let's see an example. Okay, we're going to find the location of the vertices, the foci, and slope of the asymptotes. We're going to graph this hyperbola. It is already in standard form because it's y first. The branches are going up and down. The center is found at your HK. You take those out. It's at 3, 2. And we're going to plot this onto the graph. 3, 2 is located right there. And the A value is 3, so we're putting a point 3 units right and 3 units left of that center. The B value is 4, so we're putting a point 4 up and 4 down from the center. Here's how we draw it now. It's not an ellipse. We have our points surrounding our center. The center is not actually on the hyperbola. I'm going to make these points very much larger because these are your vertices. If the branches are going up and down, those up and down points will be our vertices. What we're going to do is create a rectangle around these points. Okay, and you see I'm outlining that rectangle. This rectangle is going to be the guide to our asymptotes. Okay, and once we have our rectangle in, okay, again, here's our rectangle. And again, these will be our vertices. You connect the diagonals of the rectangle, and these diagonals are your asymptotes. What are asymptotes? Asymptotes are guides. They're the guides for how wide the branches will be. What we're going to end up doing is fitting our branches in between these asymptotes. So again, our branches are going up and down. We fit our branches going up and down between these asymptotes. And there's our hyperbola. So again, you can see our hyperbola with the branches fitting in between the asymptotes. And again, those asymptotes are guides. We use the rectangle in order to draw them. Okay, we want to find where the foci are found. The foci are found inside the branches, so the foci are going to be found going up and down from the center here. So we find our C value. Our C value is 5, so that means it's 5 units up and down from the center. So if the center was at 3, 2, we're going to add 5 to that to go up. That would take you to 3, 7. We're going to subtract 5 to it to go down. That would take us to 3, negative 3. And that is going to be the location of the foci. The slope of the asymptotes is literally just taking plus or minus your b value over a value, 4/3, and you can see that from the box. You can even check your slope. Okay, we're going to try another example. Notice this example is not in standard form, so we will have to use our completing square method and put it into standard form. Here's the steps involved in doing that. You're going to notice that one of your values, either your x or your y, will be negative. In this case, our x is negative, our x squared is negative, so that will be the second term. We're going to lead with our y's, that means. So we have our y's first, group together our y's, group together your x's, but make sure you factor off that negative 4 off both x terms. We're going to add the numbers in to complete the square. We're adding a 9 in the first one, we're adding a 1 in the second one. The 11 stays outside. Now we're doing the opposite sides of the equal sign, so we added 9, so we add 9 to the right. We added 1, which is really negative 4 times 1, so we add negative 4 to compensate on the other side. Okay, we clean it up. We got y plus 3 squared minus 4 times x minus 1 squared, and it equals 16. We want the hyperbola to equal 1, so we divide everything by 16. Simplify, and there's our equation now in hyperbola standard form. From this hyperbola standard form now, we can see that the center is at 1, negative 3. Your a value, which came from here, is 2. Your b value, which comes from here, is 4. And the branches are opening up and down because we're leading with the y. So again, the steps that we can see, we place our center. We go 2 to the right, 2 to the left. We go 4 up and 4 down. I'm making those a little bit larger because those are our vertices. The branches are going up and down. We draw our rectangle around those points. Again, knowing these are our vertices, we draw on our asymptotes, connect the diagonals of the rectangle, draw on our asymptotes, use these as a guide, and then here are our actual branches. See it a little clearer now. The next thing we need to find is the foci. Where are the foci found? In the equation of the asymptotes. And we have our vertices. We can see exactly where they are located. In the foci, we do our math, and we have the square root of 20, which is 2 squared of 5. That means from the center, again, the center was at 1, negative 3. We're going to add 2 squared root of 5 and subtract 2 squared root of 5 to get to those asymptotes. So we can write the location, get to the foci. So we can write the location of the foci like this. The slope of the asymptotes is the b over a. B is 4, a is 2, which reduces to 2. So plus or minus 2. We're going to find the location of the vertices and the foci and the slope of the asymptotes, and we're going to graph this given parabola. I'm going to help you right now. I would like you to try this, so you can pause the tape, give it a try, and then you're going to see me put it into standard form, and then you should be able to complete the rest. By putting it in standard form now, we have our x is going to lead because it is the positive value, but we're going to have to factor the 4 off the x squared and that x term. Add a blank. We have the negative y, and that negative is going to have to get factored off that y term. So the negative has to get factored off that y term as well. We're going to add the blank, and we're going to move that 9 over, and we're going to add 2 blanks to compensate for the 2 completing the squares. We're going to put in 1 there, but it's really 1 times 4, so we're going to have 4 there. We're going to put in 4 here, but we're going to compensate with negative 4. So we have 4 times x minus 1 squared minus y minus 2 squared, and now it equals 9. We need to divide everything by 9. And how we simplify this now is we go ahead and move that 4 down below. How many times was 4 going to 9? So it looks like this. Squared over 9/4. And we do want to write it like that. Over 9, and it equals 1. So from here we should be able to pull out our center. Our center is located at 1, 2. Our a value is 3/2 if you take the square root of that. Our b value is 3. Okay, and we should be able to use all that information to find the vertices, the slope of the asymptotes, the foci, and graph this. And this, again, branches are going right and left in this example. We will finish this example in class. All right, the next few slides will be devoted to writing the equation of a hyperbola given the certain conditions. This example, write an equation of a hyperbola with the vertices at 0, 7 and 0, -7, and a conjugate axis with a length of 18. Again, remember the conjugate axis is the axis that does not include the vertices. So we're going to find the center. Center is the midpoint between the vertices. 0, 0 is locating the center and how the branches open. Okay, so I mean, if you drew a quick sketch here, we have 0, 7 is over here. I'm sorry, excuse me. 0, 7 is up here. 0, -7 is down here, and the center is at 0, 0. There's only one choice. The branches have to go up and down. Okay, they can't go right and left there. So that's how we know it's opening. Branches are opening up and down. So we're using this form of the equation, putting in the center of 0, 0, which simplifies to right here. What we need to find is our a and b values. Okay. We already know b. Okay. The conjugate axis is this axis now. Okay. And if it's 18 units long, it's 9 and 9. So we're going to the right and to the left 9. We already know the other one because it's going up 7, down 7. That's a transverse axis. That's up and down, so that is under your y. So we have 7 up, 7 down, which makes a 49. And then we use the conjugate axis for our other axis going 9 units right, 9 units left, which gets us our 81. I'd like you to try this example for class tomorrow, and we will go through it in class. It's very similar to our previous example. This example we will do together. You may want to take a moment to look at this. Okay, so pause the video, look at it, see what you can come up with. All right, if I draw a quick sketch of this, we have 5, 0 and -5, 0 are the, again, let me fix that. 5, 0 and -5, 0 are branches. Midpoint will be right in the middle, so the center is at 0, 0 again. Branches are going right and left, so it's going to start with x. It's x minus 0 squared minus y minus 0 squared, and it's always equal to 1. What we need is our a and b values. We already know our a value is going 5 right, 5 left, so it's 5 squared. How are we going to find our b value? We're going to use the c. C is square root of 26. That's where our foci are found. They're found in this direction. So we have square root of 26 equals the square root of this a squared plus b squared. Square both sides. Subtract and you get 1 is equal to b squared. So b is equal to 1. So this is going to be a 1 under here. So our final solution is x squared over 25 minus y squared over 1 equals 1. This concludes our notes for today.